Hi everyone. In this video we're going to be examining the last two rules of replacement, which are also the last two rules of inference of the 18 rules that we're going to be learning in this natural deduction segment. So without further ado, let's get started. The first rule we're going to introduce is called the material equivalence rule. Now, something I noticed a while back is that there was an operator that we weren't really using. It's the biconditional. You might remember it back from when we were discussing truth tables. Now, for whatever reason, when I created a lot of the exercise files earlier, I just neglected to use the biconditional. In some circumstances where it would have been really helpful. But whatever the case, whatever the case is, we're going to reintroduce it now using this rule of replacement. So how does the material equivalence rule work? Well, the material equivalence rule says if you have P if and only if Q is logically equivalent to P then Q and Q then P. The if and only if, I want to examine exactly what that means. So this says P if and only if Q. So let's examine the first part. P if Q. This is actually talking about this second conjunct, right? Saying P if Q. That means if you have Q, then you have P. So P if Q. The second part says P only if Q. So you have P only if you have Q. If Q is in here, then P is in here. So P if Q says that Q is sufficient for P. If you have Q, then you can get P. P only if Q says Q is necessary for P. You can only have P if Q is there, and if Q isn't there, then neither is P. So P if and only if Q states sufficient and necessary conditions for P. Q is necessary for P, and Q is sufficient for P. And it states sufficient and necessary conditions for Q. P is sufficient for Q, and P is sufficient for Q, and P is also necessary for Q. So that's one of the forms of the material equivalence rule. The second form is P if and only if Q is logically equivalent to P and Q, or not P, and not Q. And so the reason this is the case is, if you remember back to when we were discussing truth tables, the material or the biconditional operator is true whenever both of the bijunks or the components or whatever, whenever they both have the same truth value. So when you see P and Q, they both have the same truth value, right? They're both true. When we see not P and not Q, they both also have the same truth value. They're both saying that P and Q are false. So it's saying if the biconditional is true, then either P and Q is true, in which case they both have the same truth value, or not P and not Q is true, in which case they both have the same truth value. So that's how the material equivalence rule works. Now that we've taken a look at the material equivalence rule, let's take a look at the last rule, which is exportation. So exportation says if you have P then Q then R, this is logically equivalent to P and Q then R. Now this rule is pretty simple to understand. So let's say you had P, right? If you had P, then you'd get Q then R. And if you had Q, then you'd get R. And what this says if you have P and Q, then you'd get R, right? So if you're able to get R, you'd have P and Q. And if you were able to get R using P and Q this way, if you had P and Q right here, you'd similarly be able to get R. You get P, then you get Q, then R, then you use Q, and then you get R. So that's why these two are logically equivalent to one another. Now that we've learned the last two rules, we're going to be taking a look at them as applied to some exercises in the next video. So I'll see you then.